Hi everybody, this is Aditya Pravakara here. So I'll be talking about the next blockage in the DevOps value chain. So a lot of interesting things happening around the software development field itself, and then we are at the very crux of a beginning of a movement there, and really a very nice time to be in here. Right? So in this session, so what's in this session? Uh, yeah, so we'll start off with a brief introduction about DevOps value creation flow, what that actually means, and then we'll look at a monolith application. So once we have an understanding of the DevOps value creation flow and a monolith application, we'll be at a very good position to spot where the blockages are, and then we will talk about microservices. And then the same monolith application that we would have looked at in the beginning, it's a very simple application so that there are varied audience, and then I just took something which will kind of resonate with everybody in the team here, and then we'll try to look at a very high level what does it mean to decompose a monolith application to a set of microservices, and then how it all ties up when it comes to the DevOps field. So this is more towards this session is geared more towards to getting to start thinking in terms of microservices, a product as a microservices, and then how the whole DevOps value creation will actually benefit when you move towards a microservices architecture. And I mean, due to the time constraint and also the brevity of the subject, to keep it brief, we'll not be going too much into detail about what microservices are and then the construction patterns of it and things like that. But based on the pace in which we go, if there are still a few minutes left in the session, I will also talk about a few more things about microservices. Yeah, and also because this is a webinar, and also the best time to ask a question is when you have it. So feel free to make it as interactive as possible. If you want me to stop somewhere, if you want me to elaborate something, or if you have a question which is of a pressing need to you right now, please do right there, as Ravi aptly said. And then, yeah, before I start, Ravi, thanks for that introduction. So it was well enough. We can start off with it. Right? Yeah. So right now, based on the attendance available, so how many of you, I mean, in your current projects or in the foreseeable future that you have, how many of you will be using microservices as such as an architectural pattern? So if you are using, then please put a word on the chat window that is available to you, and then Ravi will be able to tell me what is happening there. Okay. Yeah. So with that brief introduction of what's in it, let us start off the discussion for today. Yeah, so this DevOps value creation flow. So value creation flow, or VCF as it's called, this phrase was first coined by JP of Aritha Consulting Services, and to me, this kind of value creation flow, VCF, kind of encapsulates everything that DevOps actually aims to achieve by implementing the DevOps model. So if you look at it, so I have an image of how value would flow through in an organization, right from creating and managing of tasks to having it deployed, developed, deployed, and then monitored and all those things. So this image rightly depicts what is a value creation flow. And if you look at it, it would be really myopic to call this as a tool chain, or to call this as a workflow, or any other kind of thing. And value creation flow actually very aptly depicts this. Because it's the value that we are trying to create, and then the value flows from the beginning till the end, and where it actually sees the day of light, and customers will actually be impacted by that. So value creation flow is something that we will use in today's session also. So wherever there are references at a very high level, you can think of it as the whole development workflow, where the value moves from the beginning till the end of its life cycle. Okay, yeah. So with that introduction, let me start off with a monolith application. Right. So a monolith application kind of has changed its meaning from what it was, say, around 10 years ago to what it is now. So let us just for the advantage of everybody here. So it's easy for us to kind of visualize an e-commerce application. At some point or the other, we would have definitely used an e-commerce application. And then if you look at an e-commerce application, so there is this application framework which actually does all the logic that is required. There is a UI with which you would interact, and then that would actually have a database, and this database would actually host its products and products, reviews, customers, orders, and all those things in the database. Right? So a typical e-commerce application would be either built on a custom framework or on a framework like Magento or Magento or OpenCart. And then that would typically be a Java, PHP kind of an application, which has database which can be varied. So this basically is an entire architecture itself. But do we still call this a monolith? Yes, in today's world, so it has so become that even though it's an entire architecture, and then so you still have some kind of load balancing that you can do, some kind of replicated servers you can have, and things like that. If you look at the centerpiece here, which talks about the e-commerce application, if you think about it, this itself is a monolith. So even though it's a monolith application, because it's entire architecture, it is still scalable. But then with a setup like this, the scalability that we talk of would be about picking this whole e-commerce application and then deploying the whole application on multiple servers and then having a load balancer on the top of it. So that's how scalability is actually achieved in entire applications like this. And so that's why a monolith kind of takes a slightly deviated definition, wherein we do not talk of a standalone system anymore, but then the whole logic is monolithic in nature. So that's the monolith application that we are talking about. Okay. And now tying this back to the topic of the day, when we talk about DevOps and then a monolith application, and then we talk about blockages. Now think of this scenario wherein you have the same monolith application setup, and then tying it back to the previous slide of the DevOps value creation flow, you have had it very right, wherein you have kind of automated the whole stuff. You started off with automation of your unit test cases, and your deployment is automated. All your integration happens smooth, and then you use Chef and all those things to actually manage a continuous delivery, continuous deployment kind of a state. So everything is good there. So it seems to be like a bed of rose, but then thorns do exist there. So why I say that is, now if you look a little bit closer into the same DevOps value creation flow, the next blockage, when we talk about, okay, everything is smooth, but then where is the next blockage that can creep up with? So if you look at it, the next blockage will actually come from within your code itself. So that brings us to the topic of the day. So, but then, so what is the blockage that can happen here? So I have everything set up, everything is smooth, everything is automated. So the developer only checks in, but then it sees the day of the light, customer sees the value there. So what happens with a monolith application like this is that you definitely need a large team. So any non-trivial application which has a lot of customer base and a lot of hits happening throughout the month, you definitely need a large team of workers who are working on the whole application. And then more importantly, this whole application will be driven through a single value creation flow. So what do I mean by that? What I mean by that is this whole e-commerce application itself can consist of multiple components, wherein each of those components can grow in its own pace. So each of the components, we'll get a little bit more information on this when we try to take this e-commerce application and then try to split that into, decompose that into microservices and things like that. But then what it means is that if your analytics team asks you to throw up a new endpoint wherein they can kind of do some kind of NLP on the reviews that are there, then that change has to flow through the same value creation flow, wherein the whole of the application gets deployed again. So that becomes the blockage that we're talking about. So with any small change that you need to do, it can never be an isolated change because the monolith application, the nature of the architecture itself is such a way that because it's driven through a single value creation flow, you have to redeploy, you have to do the same testing again, albeit automatic, but still it's a heavy task, and that's where the hindrance comes from. And also, one more, it's more of a minor constraint than becoming a major constraint. All these kind of monolith applications mostly run on a constant technology stack. So that means that there may be different components in this e-commerce application which can actually benefit from a different technology stack. But then because of the nature of the architecture, all of them have to be built on the same technology stack. So we may be using PHP, Java, Springs, or whatever you have chosen. So that kind of a technology decision also requires compromises to be made. So this is where the blockages are going to come from, in spite of having a smooth delivery chain. So large team driven through a single value creation flow, and mostly a constant technology stack, which requires some compromises to be made. Right? Yeah. So at this point, if somebody wants to counter anything, or you have your own ideas about this, please feel free to drop in there. And Ravi, at this point, are there any answers to the first question that I had asked about microservices being used?
There are no responses, so probably you can ask the question again.
Yeah. So
first
from
question.
Got it. Thanks, Ravi. Yeah, from the attendees here, I just want to know if your architecture is already at a microservices level, or is it moving towards the microservices architecture in the foreseeable future? So if you belong to such kind of development team, please do ping there, because it can also lead to some interesting conversations. That's why. Okay. Yes, Ravi. Thanks. We will wait for that if anything comes up there. Okay. Yeah. So, and then the second question was, at this point, talking about monolith applications and then talking about driven through a single value creation flow, if there are any challenges to this, or if there are any counterpoints to this, please do feel free to ping in there, and then we can make this interactive as possible. Okay. Yeah. So coming back to our discussion, so any large team, it's definitely going to be difficult to steer, and then any large team, and then one huge monolith application, it really becomes difficult to be cross-functional, because now you end up with a product which has too many nooks and corners, and then not everybody will be able to work on it. So your ability to create cross-functional teams also will go down when the team becomes sufficiently large, and when your application also becomes sufficiently huge. So where does this lead us to? Right? So this leads us to a state called as development is not scalable. So that's what it's spoken as. So what does it mean? Okay, the application is scalable. It can still handle multiple requests that are coming in. But then if the development is not scalable, then the whole value offering goes down, because as the day progresses and as your application becomes bigger and bigger, the features that flow out of it becomes slower. It becomes a long duration iteration cycle, because you have to test a lot of features in your application. In other words, all the different components are really tightly coupled, and there is no single responsibility that is there for an application that of this. So this kind of is the crux of the problem that we can solve by moving towards microservices, wherein we can make the whole process of development itself as scalable. So what does it mean? So now, so that's where microservices comes into picture. So Martin Fowler has actually been doing a lot of pioneering work in the microservices architecture. For that matter, this microservices architecture has been very effectively used in a lot of large companies, Comcast, eBay, Netflix. So all of them have really found the advantage of using microservices itself. But then it's a very good definition that I found in Martin Fowler's website, which so no other definition actually kind of comes very close to what it means to have a microservice architectural style. So that's why I have just pasted this here. It's too verbose, but let me pick up a few important salient points out of what does it mean to have a microservices architectural style. Okay? So first it says that it has to be a suite of small services. A suite of small services. We'll slowly build this definition. So what is a service? So any function which can be deployable and which actually throws up an endpoint or throws up an interface for the world or other applications to connect to. So we call that as a service. So most probably these services will actually throw up a REST API through which others can actually talk to it. But not just that, it needs to use a lightweight communication mechanism. So now we're coming to the level of having microservices in an application, and then if the communication is heavy, if there is too much of marshalling of resources, too much of serialization, deserialization, objects being passed, then it's going to be a lot of overhead on what you're trying to build. So a lightweight communication mechanism. Nowadays, when we talk about lightweight communication mechanism, it's HTTP resource APIs that comes into the forefront, and that's why I have REST API mentioned here. So a function just exposed as a REST API. So I specifically put this as a function because it closely ties up to one of the features of microservices, which I will slowly reveal to you in the next couple of slides. And then, most importantly, when we talk about microservices, they have to be independently deployable. So what does it mean to be independently deployable? So that means that now we are moving towards taking a monolith application, splitting that into multiple services, small services, wherein each of the service is independently deployable. That means that for that particular service to be working, it really doesn't need any other service to be up and running. So now when we are reaching this kind of a state, we are truly moving towards a distributed application. So that basically means that you end up with multiple services running, multiple configuration files, and too many deployments happening at multiple places. So that's why this independently deployable small suite of small services which uses lightweight communication can never be a manual deployment. So it has to run through a fully automated deployment machinery. So that's where your DevOps tool chain comes into picture. So you need to have a fully automated deployment machinery for this microservices system to actually work. And most importantly, because these are independently deployable, there has to be a minimum centralized management. Okay? So this kind of defines what microservices means. So microservices, SOA, software as a service. So there are too many description terms in this area. So if time permits, I will also give you a little bit of insight into what it really means, or what's the difference between microservices and SOA also. But if you look at this, so there is this REST API, and keep an eye, let this hang at the back of your mind. So why I wrote it as a function, and then that slowly becomes much more understandable there. So now, starting with this monolith application that we started off in the first two slides, and then how do I make use of microservices? So when you convert your monolith application into a set of microservices, that's also called as decomposing a monolith application. So now, if you think about your e-commerce application, it is very easy to, this is the reason why I chose an e-commerce application. It's very easy to kind of understand the different components of an e-commerce application. So there is shipping, there are customers, there are orders, there are reviews. Now each of these can be run as a microservice by itself. So this adds a lot of powerful things. So now in the in the middle of the screen here. So this actually decomposes effectively a monolith e-commerce application. There can be multiple other components also, but I've chosen these top 4 of them. So it has decomposed it, and each of them is actually running as a service. That means that each of them have their own runtime environments to run, and each of them actually exposes their APIs through REST. So REST API or anything for that matter. So all of them actually throw up some APIs. And then your web UI that we talk of is actually composing the application based on these decomposed monolith. So this web UI talks to these REST APIs and then composes a compelling UI to talk with. If you look at it, it need not be just a web UI, because these are all REST APIs and they're using mostly JSON data to actually communicate. You can compose any different application based on any combination of these services. They need not be all 4 of them. So now it's kind of getting a little bit apparent, wherein so by splitting a monolith into these microservices, wherein each of them is an independent deployable unit which exposes an endpoint for the world to consume. So now we can have any kind of mix and match, because it's all independent. We can kind of have a mix and match between these services and then lead to multiple other services or multiple other endpoints by composing back from these REST APIs. So it looks simple because we have just taken up some block diagrams and then put them here. But then to really arrive at this kind of a decomposition is really a non-trivial task and requires a lot of planning, forethought, and a lot of vigilance also. But then what advantage does this give against having a monolith? So the first biggest advantage is, now because these are all independent deployable unit, so each of this can have its own value creation flow. That means that rather than all of this being imprisoned or being tied together in a monolith, we have kind of split them and then given the liberty for it to grow as per its needs. So for example, maybe once you set up shipping, there need not be any change in the modules that you already have, because a set of configuration is enough for you to deal with your shipping module. But then with the reviews, time and again you need to add more analytical data on the top of it. Maybe this changes at a much more rapid rate. Maybe the way you handle your customers changes at a much more rapid rate. So now all of your other application remains untouched, remains stagnant, but what wants to grow at a faster pace can use its own value creation flow and then grow much faster. So that is one advantage of it. And the second advantage of it is, because we have kind of split them into smaller services, a smaller team is enough to manage this. So a smaller team which knows exactly what is the problem statement that they are dealing with can really be cross-functional within the multiple function points in a particular microservice, rather than trying to think about the whole of the application and then not knowing every nook and corner of a huge application. So this, from a DevOps value creation flow, by exploding or decomposing your monolith into microservices, will give you all these advantages, wherein now you can really start making use of your DevOps value creation flow, and then the features can flow at much faster and a much more consistent basis, much more tested and much more stable basis, because you really have not touched, by making a change to your shipping microservices, you really have not touched the other microservices, right? So it becomes very apparent what these microservices are actually giving. So this is where the scalability of development comes. Now, along with your continuous integration and continuous deployment or continuous delivery, couple that with your microservices architecture, that actually leads towards scalable development model. So this scalable development model, each service is an independent deployable unit, implies it can grow in its own pace. We already established this. And also, apart from just having this, splitting it into microservices has much more of an impact, wherein you really have the ability to spin off a service as a different product itself. So what do I mean by that? Say over a period of time, your customers' microservices really became too good, and then you can really run a CRM product off it, not just as one particular component of your e-commerce application. Right? So it also encourages reuse. So that's the CRM example. It encourages the reuse of services within an organization. So if you already have a services which handles customers, why not make use of it and build a better CRM for your own company there? Right? So services can work off a single data lake. So this is so right now I'm actually working on one such problem wherein there is a single data lake, and then we need to build services around this data lake, which actually does a specified task from this data lake. So companies are moving towards this, wherein so all the data that they are getting, they dump it into some kind of a cloud data sync. So it can be anything for that matter, a NoSQL or a SQL or some kind of process data which is running on big data. So all of these services can actually work off that single data lake itself. So it becomes easy to maintain also, because we can also test each of these services independently. And more importantly, smaller downtime, as only a particular service needs to be upgraded and not the whole monolith application. You don't have to redeploy the whole monolith application. So that's where your continuous integration, continuous deployment.
Just to interrupt, Aditya, there's a question
Sure.
by Praveen, and the question is microservices about scalable development or scalable deployment?
Okay, so by having microservices, it definitely enables you to have a scalable development. But coming to your point, it is a good point. You can also have scalable deployment. For that matter, if you take a monolith application also with cloud services and containerization in picture, so deployment was already scalable for us. So deployment was already scalable, but then what this microservices actually gives us is, apart from making it a scalable development model, uh, because you also have smaller downtimes and smaller runtimes, deployment also becomes, I should not be saying easy, because it comes with its own with its own problems, which I'll talk about in the next slide. But then, yeah, so deployment also can be scalable, but then we already had a scalable deployment even with a monolith. Just that each deployment would now, I mean, as compared to a microservice, with a monolith, each deployment would take much more resource or much more time to actually deploy. But otherwise, your CD was actually taking care of that scalable deployment. So CD plus cloud will always give you a scalable deployment for that matters.
Okay.
Yeah. So hope it answered your question. But if you had a counter question, please do feel free to write that. Yeah. Thanks, Avi, for popping that question at the right time.
Okay.
Yeah. So now, so when we talk about microservices, what becomes the features of a microservices architecture? So by moving towards a microservices architecture, it gives you that product mindset versus a project mindset. So now, because you are building and maintaining a service as a product itself, so it encourages the team members to think of that service itself as a product, as against a project. So where this creeps in is, now if you have a monolith application, and if somebody, going back to the same example that I gave, if somebody asks you to throw up a new endpoint to do some kind of analytics, so the team is tempted to think of that requirement as a project that they have to apply on their on their monolith application, as against the microservices architecture, which encourages a product mindset, wherein now you think of your reviews itself as a product and then move towards adding more features to that product. Okay. And so that is one advantage. That's slow to realize actually, but then definitely that becomes an so product mindset versus project mindset is the biggest hindrance while you try to move from a monolith monolith to a microservices architecture. And then, so another way of thinking of this microservices architecture as a whole application is you compose an application using services. So that's what that web UI was actually doing there. You compose your application using services and not libraries. Okay, here don't get me wrong. Libraries are still used. Libraries will still help you in that reuse and all those things, wherein your services will still be using libraries. But then as against thinking of your whole application as you build an application by composing together a lot of libraries, now you start thinking about your application wherein you have a host of services to choose from. You compose your application by calling the right endpoints, by consuming the right services that are there. So even this requires a paradigm shift in how we think about an application that we are building. And now the third point that I want to make here actually ties back to that function that I used. Actually, the third and the fourth point, wherein I said that it's a function that you expose in as a REST API, right? So when I talk about microservices, okay. So services are structured. So how do I structure a microservice? They're basically structured around business capabilities. There are actually many different models around this, but then business capability kind of seems good, especially if you look at that shipping microservices. So there is a clear handoff between technology and then on the ground operations or the field work that happens in in using that shipping module. So services can be structured around business capabilities there. And most importantly, a very good thumb rule while trying to create a microservice is by making it by using the single responsibility principle. So single responsibility principle also happens to be one of the cornerstones of functional programming, wherein while building a function, you think of one single responsibility that a function should be using. Similarly, while building a microservices, you think of that microservice to be doing only one job and doing that job very well. So in a lot of material that you find about microservices, they pick this point of single responsibility principle and kind of ties it with Unix also, wherein with Unix you have a lot of tools that are available to you to work with Unix, grep, find, and set, org, and too many tools that are there with Unix. But then it is said that each of these tools do only one job and they do it very well. Right? So it's a similar kind of a parallel that we can draw here is the single responsibility principle. So that's how you will start building your microservice. And then automation, yeah. So automation is a must here. Now think about it. Right? So I had one application. And this application, I was actually doing some kind of deployment on an entire architecture. I was okay with it. But then now that I have split this application as multiple services, now I have to take care of deployment of these multiple services also. So that is why the automation of this deployment becomes paramount. So without this, microservices jungle will be a mess to handle. So this phrase microservices jungle was actually used by Comcast while they were trying to explain how their service-oriented architecture actually ended up with. So automation is a must. So coming to that point of scalable deployment that Praveen was trying to make there. So actually having multiple microservices will actually make the task of deployment a little bit difficult, wherein automation can actually help you to smoothen that process out. Right? So as with any other technology, there are drawbacks of microservices architecture also. There is no such thing called a silver bullet. Because you have multiple services, monitoring issues, so you will always have these monitoring issues. Complexity of designing a distributed system. So architecting a system in a new paradigm always has its own pitfalls. So it takes really some time to really dig through all the requirements and then build a really good microservices architecture out of it. So the designing itself is a complex aspect. Complex deployment, as I told in the previous one, otherwise we will end up with something called as microservices jungle. So initial resource overhead. That is until the user base scales up, because as against deploying one application, now you want to deploy multiple services which have their own runtime environments. Data consistency is actually a larger topic, maybe for another discussion. So there are a lot of other patterns that come into picture while talking about the microservices architecture, because it so happens that each service can have a database of its own. So there can be data redundancy, data mismatch. How do I handle those things? So this requires a much more deeper insight and thought about what we are trying to do while trying to move to microservices architecture. And because these are basically distributed architecture, so we have to design keeping fault tolerance in mind. And that's also something which kind of ties tightly with this complexity of designing a distributed system. So fault tolerance is something. So if you're really interested to dig much more deeper, so I can actually point out two of these articles which talk about the pitfalls of microservices architecture. So one is from Clayton, which says failing at microservices, and another is from this high scalability blog, which talks about microservices is not really a free lunch. I mean, there's no such thing as free lunch, right? So it comes with its own pitfalls, but then it's really exciting to actually talk about this also. But then how it all ties up together. Now, if you think about the whole deployment scenario that you have in your hands now, so you have a set of microservices. Because these are microservices, it makes that an excellent fit to be deployed in a container. So that's where your Dockers come into picture. So you take your microservices, deploy them as a container, and then these containers can very well be deployed through your regular CI/CD chain. That's where your Chef, Puppet, and other continuous deployment tools, also cloud tools, also come into picture. And then because these are services which expose an endpoint, it will make a very good fit to be on the cloud. That's where your cloud services, AWS, Azure, or your own private cloud also comes into picture. So this microservices architecture kind of very neatly fits into this DevOps culture, and also fits into this cloud systems that are coming up, and then now everything is on cloud, right? So that's where it all comes up. And then now if you look at it, I have put all of this into a cloud of its own, and then I have put this continuous monitoring. So continuous monitoring, we have always spoken about continuous integration, continuous deployment, things like that. But continuous monitoring is something, so maybe that's another topic for another day. Because we have multiple microservices, multiple deployments, we definitely need a very robust continuous monitoring system around this whole setup that we have. So this is how microservices will kind of free up from the blockages that can get created with a monolith application, and then how it very snugly fits into your existing deployment chains or your existing CI/CD pipelines, and also so it's a very neat fit into the cloud services also, right? So this is where I want to kind of bring whole of that topic together. So the different concepts of value creation flow, a monolith application, microservices, your DevOps tool chain through CI/CD, that concept of scalable development, and then this concept of continuous monitoring. So all of this together kind of neatly sums up what I wanted to talk about today. So quickly drawing up a summary of what I wanted. Scalable development should kind of become part of the psyche of the team itself. So new features, how quickly they can actually release it, minor versions, major versions, bug fixes, how can you make it really scalable, right? So your application itself may put up blockers in the delivering value. That's what we found out. The bigger your application gets, the difficult it's going to be to maneuver your application. Microservices is a way in which you can really free up your development cycles. You can only focus on the job at hand with a product mindset. So microservices architecture, definitely not a one solution which fits everybody. It has its own complexities, and it's not the only way to really achieve the scalable development also, but it can be a good way also. Microservices may also not be a good fit for a lot of application development also. So it has to be a much thought out process whether moving your application towards the microservices architecture, is it really going to give you the benefits that you want, or are you really being blocked with your current infrastructure? So all those are the choices that you will have to make once you want to move on this journey. But then a lot of big organizations have really found very good agility, very good scalability by using microservices architecture. As I mentioned, Facebook, Netflix, Comcast, eBay. So you think of any huge web scale IT company that you can talk about, they definitely have some kind of microservices architecture running in the background. So all in all, an exciting way to really architect your application in the current DevOps scene. So a lot of things are happening in this space, and that's what makes it really exciting. So Ravi, at this point, are there any questions that have actually come up?
Yes, sir. There's one question by Mr. Ashok, and the question is, who gets most benefits from microservices, whether it is developers or operation guys, or is it end users?
It's definitely the end users who get the biggest benefit out of microservices architecture. So there will be some kind of an overhead on the operations team because now they will have to monitor and make sure the deployments of, so say for example, if you have an entire architecture wherein each of that you try to split that as say 10 microservices, now you end up with n into 10 deployments that an operations team has to do. So there is an increased overhead on the ops team. On the development team, it's much more easier because now you do not tie up a development team to the whole application, but then you say that, okay, now you can work on these two microservices, and then they will now start to become experts in those areas of services. So if I have to put that in the order, customer finds the biggest benefit, developers next, and then there is an increased overhead on the operations team. Right? So that's how I would actually rate the impact of microservices.
Okay.
And also definitely a bigger impact on the design team also, because they will have to now design APIs keeping a future mind. Future possibilities in mind, and then they'll also have to. There are a lot of tools also which will help you to document and develop your APIs in a very good fashion. So the industry is evolving, maturing there. So even the design team actually has a bigger overhead while trying to deal with microservices. Good. Yeah. Hope it answered that question. Yeah. Very good question actually, because it kind of takes into consideration about all the different aspects in your tool chain.
Okay, thanks, Aditya. I see that there are no further questions posted. So thanks for probably we'll wind up the session now, unless there are any further questions. I'll wait for another 30 seconds if there are any questions. If there are none, well, we can close the session now.
Sure, perfect. Yeah, and for everybody on the call, thanks a lot. So I really enjoyed making this session. I hope even you two enjoyed as much as I did. Yeah, we will come back for more sessions on this.
Yeah, thanks, Aditya. Thanks for the insightful session. Thanks for all the attendees for participating in this session. Have a good night. Thank you.
Yeah, thanks everybody. Thanks Ravi for hosting me too. Yeah, so with this I will actually put it out of share. Thank you all.